So this is lesson 1, part 2, so day 2. So just like we just talked about our warm-up, entire versus mixed radicals. Okay, so entire is not simplified them, keeping everything in the radical. So it's an entire radical. Root 25, root 80, cube root 17 are your entire. Your mixed is kind of like a mixed number. It's got your whole number outside with something left inside. Like a mixed number, you have the whole number with a fraction, right? So kind of the same relationship there. Any questions on those two? Because now we're going to work on converting them. Okay. All right. So converting. So we have an entire radical of index 2 may be expressed as a mixed radical when the highest perfect square has been factored out of the entire radical. So that's what I've been teaching you. Find the highest perfect square, pull it out. So for example, for 72, we'd break that down to what? Good, 36 and 2. Okay, so 36 and 2. And then they just kind of do it the long way. They just show you that, remember we learned yesterday that you can multiply radicals, right? The radicals can multiply, so then we can also separate them. Square root of 36 is 6. Okay? You don't have to do this step. I never do. I just pull it out. But so then we get our mixed radical is 6 root 2 for 72. 6 root 2. Okay? Let's look at one here of an entire radical, and we're looking for a cube now. Okay? So remember, that, like I told you yesterday, you really want to understand, or not understand, I don't like to say memorize, but have down. Okay? The cubes is about 5. So we're trying to look for a perfect cube that goes into 108. 27. Okay, good. 27 times 4. Okay, why 27? Well, 27 is 3 cubed. So that's why we want to use that. Okay, so then this has the same rules. I can break it up. And then we know that cube root of 27 is 3. So our mixed radical for this cubed example is 3 cube root 4. Okay, don't get antsy and make this a 2, because cube root of 4 is not 2, right? It's not a square root. Okay, people do that on accident a lot. Just remember your index. Okay, all right, so go ahead and try a class example of 5 here. Give you a little bit of time. And then we'll go around and we'll start with Jordan. He can do A. We can come back down here. Nick S can do B. Connor can do C. And Natalie can do D. Okay. All right, so Jordan, what did you break the 320 down to?
I got 64.
Okay. Good, good.
Yeah, 64 times 5.
Okay, good. And what's your 60?
That can be simplified to 8 and root 5.
Good. So 8 root 5. Good. Okay, and then Nick.
I broke it down. I found out cube was 1,000.
Right, 1,000. Okay, don't forget 1,000. I know that's past our, I said 1 through 5. 1,000 is 10, but good. So 1,000 times 6. Good. 10 cube root 6. What's a way you can always check these to make sure that they're right? What's a way you could check these to make sure that they're right? What's that? Yeah, you could reverse it, but even a little bit easier for checking, because this should equal, root 320 should equal 8 root 5, right? So in your calculator, you can put square root 320 and figure out what that decimal is. You should get the same decimal with 8 root 5. Remember we did that yesterday? How we had the 96, the 2 root 24, and then it was 4 root 5, I think. Okay, that's how you can do that. Okay, so you can always just check to make sure that you didn't get any change in your value. Okay, good. Connor, C. Okay, 243 times 2. Good. So this came out as a 3, so you got a little bit of a tough one there. Fifth roots aren't very common for us, but yeah, 3, fifth root 2. Okay, and again, you can check that by doing it in this calculator for both of them to make sure their values match up. Okay, and the last one, Natalie, for D. Okay, so what did you break this down to? Oh, you did negative. Okay, so you did 2 So you broke this into two radicals, is that what you did? Okay, so you get cube root of, sorry, what'd you have here? 5, okay, and then what's your other one? Oh, I see what you're doing. You're not telling me the 8. Or at least I didn't hear the 8. So you broke it down to 8 times 5. Negative 20 and 2. Oh, okay. And then 4 and 5. Okay. Okay. So she's doing the tree method, which is fine. Okay, and so when you do this, this is called, like, she's getting her least common factors. Okay, so 2 times 2 times 5 times 2, that all equals 40. Okay, when we're looking for groups of 3. Okay, so she's going to take those 3 2's out as a 2, as 1 2. Does that make sense? Okay, if you don't get that, that's fine, but this is a different way of doing it, which is totally fine. Some of you might have just broke this down to negative 8 times 5, which is fine as well, because negative 8 is a perfect cube. So, you pulled a 2 out, right, Ellie? Did you take a negative 2 or a positive 2? Negative 2, okay. So negative 2, so then she got negative 4 cube root 5, which is what's left. Okay, very good. All right. Okay, a couple quick reviews here of Pythagorean theorem and distance formula is what's kind of next. The reason these apply to what we're doing now is because they use radicals. A lot of times when you do Pythagorean theorem, you're going to square root to solve for your final answer. Okay, so determine the exact length of the line segment in simplest mixed radical form using c squared equals a squared plus b squared. Okay, so what they're saying is the reason we get Pythagorean theorem is because we have a triangle here. Okay, so that part there is the hypotenuse that we're looking at. Okay, we're looking at the hypotenuse. So we want to go ab squared, which is our c squared, equals, so what's the distance horizontally from negative 6 to 3? 9, good, it's 9. And then what's the different distance from negative 2 to 1? 3. Okay, from negative 2 to 1, because 2 and 1. Okay, so that gives me AB squared equals 9 squared plus 3 squared. That's 81 plus 9, which is 90. This is where I talked about the radical comes into place. We have the square root to solve. So AB is root 90. Okay, how can we get that into simplest form? What's that? 9 and 10. Good, Bethan. So 9 times 10, and the 9 comes out as a 3. So 3 root 10 is our answer there. Okay, the next part is we're going to do the distance formula, which the distance formula is actually made from Pythagorean theorem. So you're going to see we're going to get the same exact answer using the distance formula. Okay, which makes sense because when I asked you how far, like we did, what is, here let's see, what's 1 minus a negative 2? 3, right? And we got a 3. What is 3 minus a negative 6? 9. We got a 9. So the distance formula, honestly, is just a converted Pythagorean theorem, really. That's all it is. Okay, so this is what's going to happen here. So when we do this, x2, so x2 stands for 0.2. It doesn't matter which point is 2 or 1 is 1. I'm just going to make this one 0.1. Okay, this one 0.2. So this is my x2, my y2. This is my x1, my y1. So like I just did that order with you. So we have 1 minus a negative 2 squared plus, so 1 minus a negative 2. And then we have 3 minus a negative 6 squared. Okay, that's going to give us 3 squared plus 9 squared. And we're going to get root 90 again. Which we already know is the 3 root 10. Okay, any questions yet? We're kind of on the final turn here for this unit, or this lesson, excuse me. Okay, and if I'm going too fast, let me know too, because I know you guys are hopefully filling out your notes as we go. Okay. Okay, so now we're talking about converting mixed to entire. So it's going the other way. So what do you think you would do, Melissa? So what do you think you would do, because we're going the opposite, what would we do with that 3 to put it inside? Yeah, by what? Not by the 7, not quite. Yeah, we have to square it. Yeah, Jordan? Yeah, times it by itself. So, because to take it out, we square root it. To put it in, we square it, right? Because those are opposites. So when we push that 3 back in, it's now a 9. And then, like Melissa says, then we times it to the 7. So we get root 63 is 3 root 7. Okay, that's how you move to entire radicals. It's just going backwards. Okay, we're not trying to be too complicated there. Okay, and let's look at the cube one. Okay, so same idea. Now, when we're pushing in a fraction, we want to cube a fraction, right? So when I cube a fraction, let's do a little review here. How do you cube a fraction? Yeah, fraction of the fraction, and then Bethan? Right, so we're going to hit the top and the bottom with it. Okay? You don't just hit the top, you hit all of it. The reason being is because, well, let's think about, let's go broader. What does 1/2 to the third mean? It means 1/2 3 times, correct? And in multiplication fractions, what do? You multiply across and across. So 1 times 1 times 1, 2 times 2 times 2. So that's why the cube hits both of them. Okay? So what that means is this turns into 1/8 right there. Okay. When you're timesing 1/8 to 160, what is another way of thinking of that? Whenever you time something by a fraction that's 1 over something, you're really just, dividing. You're dividing by 8. If I time something by 1/2, I'm really dividing by 2. If I time it by 1/4, I'm dividing by 4. So 160 divided by 8 is 20, I believe, right? Okay, so we should have cube root of 20. Okay, we made that an entire radical. Okay, let's go around here and have you guys try these again. So, alright, so Melissa, what did you get for A? Root 12, right? You pushed that in as a 4, and it gave you, so then you had 4 times 3, so root 12. Okay, good. Alright, Jake, how about B? Okay, good. And what did you do with that negative? Okay, good. Since we pulled it out, you're just going to leave it outside because you can't push a negative in. So I know you're saying like you can still square a -5, but we can't ever tell if it would be a negative or a positive, so we just keep it outside. Okay, so you're right though, so then that's 25 times 6, so it's 150. You want to keep it just like that. Okay, Bethan? Okay, and then this one we can put the negative in because cubes are okay with it. So you said cube root of what? 384. Okay, good. Okay, oh, and it's negative, sorry. Okay, and D, 4th root of 1250 is correct. Okay, and then Wes, you got the fraction. Okay, 51.2, or you can leave it as a fraction, and I kept it as a fraction, so I did 256 over 5, which I think you're still fine. Okay. All right, any questions on that? All right, cool. So the last thing here is we're just going to go ahead and just order these from greatest to largest. So based on what we were just doing, what would be a good idea to help us understand without a calculator which is bigger? we have to put them all in entire radicals. Because if I have entire radicals, they're a number, right? So, for example, if I put this in, that's going to be 9. That's going to be root 54 is what that is. So if I do this one, it's 36 times 3, it's 108. So which one's bigger? The root 108. Okay, it's a good way to help you order. Okay, so I'll keep doing that. We just have root 18. We leave it. What would this one be? 28. Yep. And then here? 98. Good. So this is number 1. This was number 2. Number 3. Number 4. Number 5. That's how we'd order them. Okay, so the order would go 6 root 3, 7 root, wow, 7 root 2, 3 root 6, 2 root 7, and root 18. Okay, so that would be your order. All right, very good.